Now that we've graphed these logarithmic functions with no transformations at all, no shrinking or stretching, just a normal log with different bases, now we're going to look at logs with some of these transformations. So if we look at this one here, y equals 3 log base 4 of x, our transformations, reflection, we have none. There is no shrink or stretch. Sorry, there is no reflection. Our a value is positive. As for shrink or stretch, we do have a shrink or stretch because our a value is 3. So we have a vertical stretch by 3. Translation, we don't see any plus or minuses anywhere. So no, we don't. So to graph this, we're going to do the same thing that we did graphing exponential functions, where we're going to start with 1, 0, and 4, 1, our base, 1, and then we're going to make a third row or third column in our table, and we're going to multiply all the y values by what our a value is. And in this case, it is 3. So we're going to multiply all the y values by 3. 0 times 3 is 3. Sorry, 0 times 3 is 0, and 1 times 3 is 3. So we're going to ignore that middle column, and we're going to graph 1, 0, and 4, 3. And our asymptote is still going to be x equals 0. And our graph looks like that. So it kind of looks the same as what we graphed earlier, except this is a vertical stretch. Asymptote, again, is going to be x equals 0. And the end behavior as x approaches 0, because that's what the left side's doing. The left side's not going to infinity. The left side is getting closer and closer to 0. The y values are going down to negative infinity. And as x approaches positive infinity, the y values are going towards positive infinity. You know, look at the graph. It's going up slowly. Domain. The domain is going to be 0, infinity. And the range of logs is always negative infinity, infinity. And just a double check, 0, 0, 0. So we're confident that we did this correct. Now over here, we're asked to find the inverse of the function. So remember, the inverse, you're going to switch where x and y are. So x equals 3 times the log base 4 of y. And since the log is already by itself, you can switch this to exponential, but let's first divide by 3. That's a better idea to do that. So we have x over 3 equals log base 4 of y. Now we're going to change this from a logarithmic function to an exponential function. We're going to go from log form to exponent form. Our base is 4. And remember, log equals exponents. So this up here, this x over 3, that is my exponent. And then it's going to equal to y. So the inverse here is 4 to the x over 3 power. All right, now on the next page, we have some more stuff going on here. We have an x minus 6 in the parentheses and a plus 1 on the outside. So that means we're going to have some translations. So R, S, T, reflection. There is no negative sign in front, so we have no reflection. Shrink or stretch, we don't have an a value, or that a value is an invisible 1. So we have no shrink or stretch. But when it comes to translation, we are going to be translated right 6 and up 1. So we're going to graph this without the translation and then move each point based on the translation. The same way that we did square root and cube root functions and exponential functions. So this should be a little bit easier this time around. So our table here, x, y, 1, 0, and our base is 2, so 2, 1. And normally you would say, oh, well, you're going to multiply all the y values by a, but our a value is 1, so you would still get the same y values if you made your third row. So you don't necessarily need to do that. You can if it helps you, but it's going to be the same points. So we have 1, 0, and then we have 2, 1. So our graph would look like this, but we're going to move each point right 6 and up 1. So this point right 6, 1, 2, 3, 4, 5, 6, up 1. This point here, right 6, 1, 2, 3, 4, 5, 6, up 1. So this translated graph is going to look like that, which means our asymptote is also shifted 6 units to the right. So this is our asymptote at x equals 6. And remember, when we did exponential equations, when we graphed those, our horizontal asymptote shifted if we had a vertical shift. If we were shifted up 3, then our asymptote went up 3. If we went down 7, then our asymptote went down 7. Now with logs, it's with your x values. So our x translation, or the horizontal translation, is right 6. So that means the asymptote shifts right 6. Now the end behavior is not going to be as x approaches 0. It's as x approaches our asymptote, which is 6, y is approaching negative infinity. And as x approaches positive infinity, y is also approaching positive infinity. The domain will be 6, infinity, and the range is always negative infinity, infinity. And again, these match, so we're in good shape. To find the inverse, we'll switch x and y. So x equals log base 2 of y minus 6 plus 1. So we have a lot going on here. So first, we're going to subtract 1 from both sides. And that's going to give us x minus 1 equals log base 2 of y minus 6. Now I can go from log form to exponent form. 2 is our base, raised to the x minus 1 power, because the log and exponent are on opposite sides of our equation, equals what we have left over. Y is still not by itself, so we need to add 6 to both sides. That 6 is not being added to the exponent. So 2 to the x minus 1 power plus 6 equals y, which makes the inverse 2 to the x minus 1 power plus 6. So you still need to know your rules to convert from log form to exponent form. All right, now the last problem here, we have a negative sign in front. So that means we are going to have a reflection. So we do have a reflection. but we don't have a number in front with that negative sign, so there's no shrink or stretch. And a translation, we have translated to left 4. So our table, we're going to be at 1, 0, and our base here is 3, so 3, 1. Now that negative sign in front, you can make a third row for negative y and take each of the y values and multiply by negative 1. Ignore the middle row. And we're going to graph 1, 0 and 3, negative 1. So what this will look like now is your graph is going to go this way. And now we're going to move each point left 4. So 1, 2, 3, 4. 1, 2, 3, 4. So the new graph, the translated graph, will look like this. And our asymptote has also moved left 4. So the asymptote is going to be at x equals negative 4. Our end behavior, as x approaches negative 4, the y values are going up. Look at this end. As we get closer and closer to negative 4 on the x-axis, the y values are going up to infinity. And then going towards infinity, when we look at the x values, the y values are going down. The y is going to negative infinity. Our domain will be negative 4, infinity. And the range, since this is a logarithmic function, can be that, negative infinity, infinity. Double check that these three match up. All right, we're good there. And then finding the inverse, switching x and y. So x equals negative log base 3 of y plus 4. I'm going to divide by negative 1 first to get rid of that negative sign here. So x divided by negative 1 is going to be negative x. So negative x equals log base 3 of y plus 4. Then we look at our base, which is 3, and raise it to the negative x power, since the log and exponent have to be on opposite sides. And that's going to equal what's left over, y plus 4. Subtract 4 from both sides. That's going to get us 3 to the negative x power minus 4 equals y. Y is now by itself, so that means our inverse is 3 to the negative x minus 4. So I hope that you're realizing that graphing these logs at first may have looked a little intimidating or confusing, but it really isn't that bad once you look at everything and see how it all fits together. So I hope that this makes sense and that it makes life a little bit easier. Thank you for watching. Make sure to like and subscribe.